Okay, good evening, ladies and gentlemen, and welcome to this Saturday evening edition of the live. And we are going to go deeper into the concept. One part of the today's session we had covered a few days ago, if you remember. We had covered something called CPCPK. I don't know how many of you were there in that session. That happened on 7th of, I think, 7th of April, I believe. Yeah, how many of you were there on that session of CPCPK? Just give me yes in the chat box or me in the chat box. How many of you were there? Uh, yes, okay. So Preeti was there. Who else? How many of you remember CPCPK session, live session, which happened on 7th of this month? I think it was 7th, yeah. एक ही बाकी कोई नहीं था. Okay, doesn't matter. We'll start from the basic, the scratch, so that you guys will understand. Okay. Now, how many of you are aware about DPMO? Just give me in the chat box. How many of you are aware of DPMO? DPMO किसको पता है? DPMO. Just type me in the chat box. The people who are aware of DPMO segment, just give me in the chat box so that we'll start the session. Now, the topic which I'm talking about is about discrete process capability. So first we'll understand what is capability, and then we will understand um, what is the importance of it, and what are the basic different types of it. Close it, please. Just a second. Haji. Okay, so here we go. Let's begin with the topic of the day, which is discrete process capability. But in this DMAC framework, DMAIC, which we call it as DMAC framework, there are two phases in which we actually check the process capability. Okay. The first phase is called as the measure phase, where we will check current process capability. And in the control phase, we check the improved process capability. Everybody make a note of this. And I'm talking about process capabilities here. Process capability. So in this DMAC framework, we actually do this twice. One, in the measure phase, which is about the current process capability. What is my current process capability? And the second one happens in the control phase, which is after improvement. We do this again, and then we compare both, and we are expecting some improvement in the process capability. But what is process capability? That is a question. What is process capability? The process capability is nothing but the ability of your process to satisfy the requirement of the customer. In the simple word, the capability of your process to cater the requirement, to satisfy the requirement of the customer. Let's say customer is asking the delivery within 30 days, 30 minutes, let's say. Pizza delivery. Well, let's take a simple example of pizza delivery. Is your pizza making and delivery process capable enough from order to delivery that the entire process, can it fit within the 30 minutes? That is called as process capability. Are you clear with this? Just type yes in the chat box. Ability of the process to satisfy the requirement of the customer. That is called process capability. Are you clear, everybody? Yes? See, I'm just giving you multiple examples. Just try to see the parallel of your own process. Okay. The same pizza delivery process, the ability of the process to satisfy the taste of the customer. Okay. If customer says on the scale of 1 to 10, your pizza should taste 8 and above, then I will accept it. On the scale of 1 to 10, on an average, it should taste 8 and above. So that is the process capability on the test. The first example was on the delivery time. Ability of deliver within time. You can find out process capability on the delivery time. You can find out process capability on the test. You can find out process capability on the hygiene. You can find out process capability on the hospitality of the people. Let's say there is a restaurant, hospitality के ऊपर भी process capability find out कर दिया. So all these parameters are called as critical to quality parameters. Critical to quality parameters. So process capability can be found out in each parameter separately. So in our project, we find out the process capability for what we are doing the project. Whatever project we are doing, for that we actually check the process capability. Are you clear with this point? Just type yes in the chat box. If I'm doing a project on test, so I will do a process capability on the test. Is the process capability to deliver as expected? Is it customer? Is it correct? Is it the capability to deliver as expected? Exactly. Exactly. Expected by the customer. Right? So once the customer has decided, I want this, what is your ability to deliver that? That is called process capability. In a very simple word. Are you clear now? I've given you multiple examples with the same restaurant and food example. So delivery, test, hygiene, hospitality, all these are various critical to quality attributes on which you can find out process capability of your process. Now, you have to choose which is your project accordingly. So for test, that will be a different project. For delivery time, that will be a different project. For hygiene, that will be a different project. Hospitality, that will be a completely different project. So according to your project description, project identification, your process capability will be decided. Clear, everybody? Just type yes in the chat box if you're clear with this point before I go further into this. Super clear? So it is decided on what is the challenge you are dealing with. Accordingly, process capability you will have to calculate. Okay. Super. Now everybody knows that there are two types of data we deal with, right? Can you just type in the chat box what are the two types of data do we deal with in the in the statistics in Lean Six Sigma? What are the two types of data do we deal with? Super, very nice. Continuous and discrete, very good. So when it comes to data, we all know that there are two types of data, right? One is called continuous data. Continuous, and other is called discrete data, right? Now, continuous meaning the data which can be measured on a continuous scale. The data which can be measured. My screen is not being shown here. Is my screen visible to you? Because I've got three screens right now in front of me and everything is visible. Yeah, Ranjit ji, maybe if you're on mobile phone, just scroll around. There might be one screen which will be there. Otherwise, just log out and log in again. Okay. Okay, hai, Abhi? Very good, very good. Chalo, sort it out. So, continuous data meaning the data which can be measured on the continuous scale. That is called continuous data. Okay, for example, temperature, speed, pressure, height, weight, length, all these are measured and that is continuous data. And the data which can be, so on the continuous data, let me give you examples of the data like length, weight, temperature, pressure. Okay, all these things are continuous data which can be shown with the decimals. We can say that this is 1.2 meters, 1.3 meters, 1.4, 1.5, 1.6. So it is like on the decimals, continuous scale we can mention. On the other side, discrete data is a count data. So continuous data we generally measure and discrete data generally we count. Now what kind of data? Let's say number of people in the room. Number of people. We count number of people. We don't measure number of people. Okay. So we count number of people. Right? Number of people. number of pass students, number of fail students, male, female, go, no go, how many pass, how many fail, how many accepted, how many rejected. All these are called discrete data. The count data, it's called discrete data, and the measured data, it's called continuous data. That's what we always say. If I have to count the number of people in the room, we don't say go and measure number of people. We always say go and count number of people. And we never say that go and count the weight. We always say go and measure the weight. See the difference between our own subconscious terminology also, we use the same thing. Are you clear? So whenever we are measuring something, it's a continuous data. Whenever we are counting something, it's a discrete data. Are you clear with this? Just type yes in the chat box. ये differentiation clear है in your mind? ये differentiation clear है? Very simple, clear? Yes. See, new people, if you are, I'm just starting from the scratch. This is the green belt level stuff, very basic. Okay. I am little louder, or I have to speak little louder. I think इससे ज्यादा आवाज करना मतलब मेरा आवाज वैसे ही बड़ा है. मैन्युफैक्चरिंग सेटअप से आता हूं तो see, we used to work with the machines. Okay, so my voice is naturally very loud. Okay, why we say count will be the data we only positive numbers or negative numbers too. Now, for example, continuous data में negative numbers है, possible है. Okay, give me one example, na Priti, where you have negative count number. Just discuss about it. If you have any process data which has a negative number which you are counting, can you think of anything like that? See, I can think of negative number like negative temperature. Like temperature drops below zero, na, it becomes negative. Correct? Yes. Even northern side, even in a lot of part of South Pole and North Pole, we have temperature going below zero so many times. Below 20, below 30. In Himalayas also, there are a lot of spaces where we go negative temperature. So temperature is a continuous data, which can be measured on a continuous scale, or either positive, either negative. It remains continuous. But in case of discrete data, if you can think of anything which is negative, two sets of discrete data, which is our new set of data. Yeah, what is that data? What is that? Can you just elaborate a little? Which example? Which kind of discrete data we are measuring? See, difference can be positive and negative. That's not a problem. But what kind of data are we counting? That is what something which we are dealing with here. Okay, clear? Anyway, so basic fundamental is clear, continuous and discrete, right? Now, when it comes to continuous data, we measure the process capability in CP, CPK, and Z score, or we can say the Z bench score. Make a note of this. And this session was taken, I think, on 7th of April, if I'm not mistaken. Let me check out quickly. On 7th of April, we had taken this session. Yes, I was right. It was 7th of April. You can just make a note of this, or maybe let me just give you the link right away in the chat. You guys can check out later. This is the session which we had taken. You can just check out this. This is the link. Please check out this session. And this session, we only covered the CP-CPK, which is for the continuous data. All right. Now, today, we are discussing the second part, or the counterpart of it, which is when it comes to discrete data, when it comes to the count data, okay, we are using PPM and DPMO, which is going to be discussed today. Okay, so we are going to discuss if we have a discrete data, how do we basically check the process capability? That's what the name of the topic is, discrete process capability. So today we are going to discuss about PPM and DPMO, and I'm going to decode a lot of things deeper into this. Clear? Just give me yes in the chat box. Two sets of period or employee participation in training sessions. Yeah, so comparative data, Preeti, I got your point. But the data which we are capturing here, no, employee attrition again, and the participation in the training session, which is again the attendance kind of a data. And both data we are just counting or compare. Let's say there are 50 employees, out of which 40 people attended, 10 people absent, right? So that kind of data, which is again a discrete data only. Correct? So number of people attended, not attended. It's a discrete data. So see, now if 100% attendance is expected, but they are only 90% attended, so it is -10. That is what basically your question is, but it comes in the discrete format only. Clear? So basically what we are talking about is a discrete format where we are actually counting the number of, even attrition also is a discrete data only. Okay, everybody with me? So we are dealing with PPM and DPMO. So let's understand the chronology of how it got evolved over the period. Just take a screenshot of this quickly. Data, continuous, discrete, types of data, length, weight, temperature comes into continuous, discrete, number of people, number of fail, number of pass, number of male, number of female. That will be a count data or discrete data. For continuous data, we have CP, CPK, the Z score, which is Z bench, as the process capability indicators. And for the discrete data, we have PPM and DPMO. Just take a screenshot, just type yes, done karke in the chat box. So that I want to scribble the chronology of how it got evolved. You know, done, 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 taken, or if you're taking the notes along with me, that will be great actually. And I would, if you're not traveling. Super. Thank you very much. So let's understand this. Earlier when we in the industries, basically we used to use, in case of, let's say, rejection or defects kind of thing, we used to use one very simple uh, formula, which is nothing but percentage. Okay. So, or we can say percentage defective. Correct? Percentage defective was a very, very commonly used parameter for our performance. Okay. For our capability. Like this process is generally delivering 95%, first time right. 95%, meaning out of 100, 95 pieces will be absolutely first time right without any defect will come out. That is the very basic understanding of percentage. Now, what happened after some time, over the period of time, industrialization boomed. Okay, the mass production, etc., started. So, percent was not enough parameter for us to understand, and that's where it comes into picture is per million. Because when the industrialization, the mass production, etc., began, then percent meaning per 100 was not good enough denominator. They wanted to increase the denominator. So instead of percent, they started measuring that in per million basis. And that's where something called PPM comes into picture. PPM stands for parts per million. Exactly, PPM. Now, instead of cent meaning it's a short form of a century. Percent is the short form of per century. Century meaning 100. Correct? Similarly, per million, which is parts per million, in the simple word, just put DPPM. That will be a better. What is DPPM? Defective parts per million started to started to be used in the industry. Defective parts per million. Yes, water quality में भी ppm use होता है. Exactly. Clear है? So see the chronology. Earlier it was percentage defective. So out of 100%, let's say 95% is okay product, 5% rejected. Now after that they started using ppm or dppm into. So what is the formula? The same formula. So same formula. How many? Let's say 100. Out of 100, let's say 95 are rejected. Then how many will be rejected out of 1 million? That is a simple formula of DPPM, or defective parts per million. Out of 1 million parts you have produced, how many parts will be defective? That is called defective parts per million, DPPM or PPM. Both are same. Don't get confused between PPM and DPPM. Clear hai? So PPM is nothing but DPPM, the same thing. Sachinji says, sorry, sir, I'm joining late. Doesn't matter. We are just starting. Okay. So what we cover, Sachinji, yet now is there are two types of defects, two types of data, continuous data and discrete data. Okay. In the continuous data, we have the measurable aspect like length, weight, height, temperature, pressure. All these are which can be expressed in decimals are continuous data. For continuous data, we have CP, CPK. Correct? CP, CPK and Z-score are the process capability indicators. When it comes to discrete data, where we have count data, in the count data, how do we check the process capability? We have PPM and we have DPMO. Okay, so we are just explaining what is that chronology in which these formats arrived. Okay, so earlier it was percentage defective we used to calculate. Okay, so out of 100, 95% is okay product. That means remaining 5% are defective product, or 95% of the okay product, customer will accept it. Okay, so it was percentage defective. When industrialization happened, when the mass production started, so percentage turned into per million, and that's where ppm came into existence, which is parts per million or defective parts per million. That's what I'm explaining. Out of 100, if I'm rejecting 95, so out of 1 million, how many I will reject? Okay, so what will be the answer? Which will be 9,50,000, is it? Can you just calculate this for me? If I am rejecting 5 out of 100, out of 10 lakhs, how many I will reject? Everybody? 9.5 lakhs? Exactly. So 9,50,000 will be the no, this is the 95% rejection, by the way. This is defective part. So if this is defective, meaning it's a very bad lot. Understand this. Out of 100, out of 195 are rejected, only 5 are accepted. That means a very, very bad lot. All right. Okay. Yeah, that's a worst lot. You have to shut down your process and do something else. Your process is not capable enough. Okay. So defective meaning how many are not falling within the specification limit. Okay. Let's say in the pizza delivery, how many pizza out of 100, how many pizza you did not deliver before 30 minutes? That is called defective. Okay. Let's say, for example, in the same example, let's say 100 delivery data I have taken, out of which we found that 5 deliveries were defective deliveries. Okay. So let's say the 5 deliveries were defective deliveries. That means out of 1 million, there will be how many deliveries? I think 50,000 deliveries will be defective delivery. Are you understanding this? And this is called DPPM, or defective parts per million calculation. Everybody's clear about this? Just give me yes in the chat box. How many defective parts you are producing out of the total parts into 1 million? It's called defective parts per million. Very simple calculation. Clear? Yes? Clear hai everybody? Just give me yes in the chat box. So percentage and DPPM is clear? Okay, very good. Then comes the entry of Six Sigma. So after Six Sigma, what happens? And this is a very important point. Just try to understand this. Now in Six Sigma, They started focusing on not the defective, but the defect. Let me just clarify this first. So when I say defective parts per million, I'm referring to the entire product. But in the product, there could be multiple defects. Just try to understand this. Let's say the product is, imagine the product is, let's say a shirt. I am making shirt, or it can be water bottle. It can be a laptop, or it can be anything. It can be a product. It can be service. Anything. Understand this? Let's consider a shirt, or it can be pizza as well. I'll give you both examples. Okay. Now, in the shirt, this is called one unit. Entire shirt is called one unit. Or we can say a part. Part meaning the entire unit I'm talking about. One shirt is equal to one part is equal to one unit. Now, in one shirt, if I'm making shirt, what kind of defects, let's say, if I want to check how many types of defects can come in the shirt, let me just quickly find out that. Okay. So in the shirt, what kinds of defect can come? Can you just type in the chat box? In one shirt, what kinds of defect generally you basically observe? Yes, buttons. Yeah, exactly. So button missing. Okay, missing buttons. What else? It can be, yeah, stitching issues. Fantastic. So it can be a stitching issue. What else? It can be the stain on the cloth, right? So the stain could be there. What else? So stitching issues, fabric damage, the size, improper sizes problem are there, right? Very good. So measurement size, we can club together that part. Fabric damage. Okay. Material quality and fabric damage, we can just club. So the material and the fabric defects, we can club together. So understand this. So let's say these are the 5 different types of defects which can come. Understand this. Now, the traditional way of checking the quality, this is the most important point. If you can understand this point, post Six Sigma arrival after 1980s and 90s, 1980s and 1990s, this is the biggest revolution which has happened. Now understand this. Huh? This is very important. Let's say I'm the quality checker in this company, let's say, and I'm checking the shirt. The moment I found the button missing, I will reject the shirt. Understand this. The moment I found a first defect in my product, I will reject the entire shirt. Yes or no? I will not let it pass my quality check. But because of which, what is happening is, I am not observing the other defects which are potentially there. I'm not observing stitching issue. I'm not observing stain. I'm not observing whether the size is proper. I'm missing the other defects. In the data, I'm only capturing one defect and rest of the defects are getting neglected. How many of you got this point? Just type yes in the chat box. The moment I found first defect, I will reject it. And that was the biggest factor in defective part per million. Now, if you work on that particular defect, okay, what about the rest of the defect? You are not observing how many defects are there. And you are quite possibly miss out those defects. And if you miss out on the data, you will not work on the data, on those defects, right? Because the data will not give you that significant number. And that was the significant term. And from the defective parts per million, we shifted to defects per million opportunity. DPMO. Instead of DPPM, we shifted to DPMO. Everybody, please make a note of this. DPMO. DPMO stands for defects per million opportunity. Make a note of this. Defects per million opportunity. Defects per million opportunity. Before I deep dive into defects per million opportunity. First, let me identify, let me explain you, how do you finalize the defects? There are certain rules, there are certain ground rules we have to follow. There are three major rules in this which you need to follow to basically make sure that those defects have to be identified. What are those rules? Let's write down. So the rules to define the defects. But before that, are you clear about the defective and the defect? Defective meaning the entire unit, entire shirt is called a defective unit, and the defects meaning within that shirt there are multiple defects which are actually observing. Are you clear with this distinction? Just type yes in the chat box. Are you clear with this distinction? Just give me yes. Super clear hai ye. Yeah. So let's focus here. Product becomes defective. Let's say that in the laptop, there could be multiple defects. Let's say this, there could be a the screen problem. There could be the, the key problems. There could be the mouse problem. There could be the camera problem. So entire unit has got multiple defects. Okay. Even one defect comes, that makes that product laptop defective. So defective is used for the entire product, and within the product there could be multiple defects. Are you clear now with this? Just give me yes. So defective meaning entire unit can be declared as a defective unit. Okay. And when it comes to defects, one entire unit can have multiple defects associated with it. Clear? So defective is for the complete unit, and defect is within the complete unit. There could be multiple defects. Are you clear? Once more, brother Vikramji, are you clear? Who else? Simple hai? Very good. Anyone else? Sanjay ji, are you clear? Just give me yes in the chat box. Super, amazing. Chalo, so what are the major three factors we need to consider while defining the defects? The first one is, it should be critical to the customer. Now, what I'm writing is, how do you define those defects? What are the principles of defining the defects? It should be critical to the customer. That defect, if the defect comes, it should be very, very critical for that customer. For example, in the pizza, the taste is very critical for the customer, yes or no? Hygiene is very critical to the customer, yes or no? The delivery time is very critical to the customer, yes or no? So it should be critical to the customer. That should be considered as a defect. Okay, second point is, you can club similar defects. Write this down, I will explain you. You can club similar defects. What does it mean? Clubbing similar defects meaning, let's say for example, button missing on the, on the top, button missing on the collar area. So you can club these defects and call button missing, just to avoid unnecessary inflating the numbers. If one button missing or two or three button missing, you can club together as button missing. Okay, let's say you are making water bottles, leakage in the center, leakage on the top, leakage on the bottom can be considered as a leakage, as one defect. So you can club similar defects. Are you clear with this? So critical to the customer, you can club similar kind of defects. Okay. And you should consider frequently occurring defects into this. Number 3 is consider frequently occurring defect. Let's say on the other side, if one defect is there, it had come once in 20 years. Those kinds of very rarest of the defects should not be considered in this defect opportunities. Okay. So frequently occurring frequently occurring defects should be considered. Defects to be considered. Okay. So if you basically take care of these three major elements, critical to customer, club similar defects, and frequently occurring defects, if you consider, then you define for your product what are the major defect opportunities. So in this shirt, these are the major defect opportunities. Here you can see they are called as defect opportunities. What is defect opportunities meaning? The potential defects which can come. So we can either have button missing, we can either have stitching issue or a stain or a size problem or material or fabric problem. These are the 5 defect opportunities in entire shirt we can have. And then we will actually check the product, and then we will find out how many defects have arrived out of these 5 in each shirt. And that's what we will capture, and that is called DPMO, defect per million opportunity. I'll give you the formula for this. Are you clear till now? Just type yes in the chat box. Till now, everybody's clear with me? Super. Amazing. Now let's take the DPMO formula. Okay, so we have identified the defect opportunities, on the shirt, and let's find out the DPMO formula. What is DPMO? Defects per million opportunity, and the formula is this. So the formula for DPMO is equal to number of actual defects. Make a note of this. Number of actual defects. First, write down the formula. I will basically explain you. Number of actual defects divided by number of defect opportunities. Defect opportunities multiplied by number of units. Unit meaning the entire product or the shirt, let's say. Yeah, the potential defect. Exactly. So I call defect opportunity nothing but potential defect. Exactly. Whole multiplied by 1 million, which can be expressed as 10 raised to 6 as well. 10 raised to 6 meaning 1 million. Okay, 10 lakhs. So in the same example of the shirt, imagine every shirt has got 5 potential defect opportunities. Correct? So in the denominator, number of defect opportunities are 5. We have defined them as 5. Okay. Now, let's say if I check 100 shirts, so number of units are 100. All right. So I check 100 units. In every unit, 1 unit is equal to 1 shirt. Huh? Every unit has got 5 potential defects. Potential. Then I will check how many of them have arrived, how many of them can be seen. Okay. I found 50 defects out of it. So number of total defect opportunity was 5 multiplied by 100, which is 500. Out of 500, I could find out 50 defects, whole multiply by 1 million, which is 10 raised to 6. Can you just give me the answer? Give me the answer in the chat box. Calculate this and give me the answer. 50 divided by 500 into 1 million. Everybody? Number of defect opportunities are 5, which is buttons missing, stain, the size problem. Okay, those are the 5 defect opportunities we found out. Right? 50 are the actual defects I found. For example. Okay, clear hai? Yes. So let's find out. Let's say I take first shirt. Imagine I take first shirt. I found out there is no problem in that shirt. I check all the defect opportunities. I pass that shirt. I take the second shirt. I found there was 1 button missing. So I will count one defect found. Okay. Rest, no defects found. So I will, keep this that shirt aside. I will take the third one. So I will check for every shirt. I will check all the 5 defects and how many defects have come. So 50 defects I have found out, right? So out of 500 defect opportunities, because 5 in every shirt multiply by 100, the total defect opportunity is 500 in the denominator, and I found 50. So in the 1 million defect opportunities, it's very simple. Out of 500, I found 50. Out of 1 million, how many I will find out? So the answer is 1. Is it 1 million? 1 million kaise hoga? It is 1 lakh. It should be 1 lakh, right? It is not defective. 50 is not defective, Priti. It is defects, not defective. Understand this? It is defects, not defective. We are not calculating ppm here. We are calculating DPMO, defects per million opportunity. Clear hai? Yes. So these 50 could be from from the 50 shirts, or it could be from the 20 shirts, because in 20 shirts there could be 50 defects. One shirt can have multiple defects. Yes or no? Correct. That's why 50 are defects, not defective. So the answer is 1 lakh. That means this DPMO is called defect per million opportunity. So we have 1 lakh defects per million opportunity right now. Now, there is one table which is given in your green belt curriculum as well. Let me just share that table with you. And then I will give you an Excel sheet as well to calculate. Okay. So this is a table, and this table is called as DPMO conversion table. DPMO, defects per million opportunity. DPMO is count. No, it's a count unit. Unit will be count. How many number of defects? It's count, right? 1, 2, 3, 4. So it's a number. Number is a unit itself. Yes. Okay. Now, so what this is called DPMO. So from the DPMO, we can convert that into sigma level as well. Okay. So look at this table, guys. So our DPMO calculated was 1 lakh, right? So see, there are 3 parts into this. One is called the yield, other is called the sigma level, and other is called the DPMO. Okay. And because of the height of the table is the large, so they have just divided into 2 parts. Basically, it's the same thing. It's a continuation. Okay. So starting from 6 sigma to 0.1 sigma, this entire table flows. Okay. So pehle yahan se jayega. So it goes like this, and then it goes like this. All right. So ye 2 part hai table ke. Now let's look at this. What is included? So here we are calculating DPMO, and corresponding sigma level we have to calculate. For example, now understand, it's very simple. When the DPMO is 3.4, the sigma level will be 6 sigma. Are you clear? When we have 3.4 defect per million, we have a 6 sigma level of performance. Are you clear? Even in the yellow belt also. When we have 230 defects per million, we have 5 sigma level. Do you remember the table which I explained in the yellow belt as well? When we have 6,210 defects, we are at 4 sigma level. Clear hai? Similarly, whenever we have 1 lakh DPMO, it will come somewhere here. 96,000 to 1 lakh 15. So somewhere in between. So our sigma level would be around 2.75 के आसपास हमारा सिग्मा लेवल लगेगा. That means my current process sigma is 2.75 sigma process. Clear? So you can refer this DPMO table easily. Are you clear with this? Just give me yes in the chat box. So you calculate the DPMO and you just refer this sigma, this convergent table, and accordingly you can find out your sigma level, and this is your process capability with the discrete data. Clear hai? Just give me yes in the chat box. Super clear, everybody with me? Now just try to understand. Now just try to understand this. Very simple. Now when your process is a 6 sigma process, what does it mean? It means It means, just try to understand this, 99.99966% product. This is my LSL and this is my USL. Lower specification and upper specification limit decided by the customer. Okay. So 99.99966% of the product will fall within the specification, will be accepted, and that is called the yield. If you see here, just focus here. 99.99966. So what is rejected? What is coming out? Coming out is nothing but 0.00034 percentage is rejected. Percentage 0.00034 percentage is rejected. If I convert that percentage into per million, that comes to 3.4 per million. And that is nothing but DPMO. How many of you got this? Just type yes in the chat box. If I convert this 0.00034 percentage, which is rejected, into million, it becomes 3.4 per million. Clear everybody? Just give me yes in the chat box. Super clear hai ye? The same table is applicable. The same table is applicable here. Clear? Any doubt into this? So similarly, let's take another one. Let's take the first one over here. Okay. So when it comes to 3 sigma process, 93, for example, let me draw this again. So this is my process. And in this process, let's say 93.3200 percentage will be accepted by the customer, and 0. What is that? 0.00066 percentage will be rejected, which is nothing but, if I convert into DPMO number, it will be 66,800 per million. Are you clear? Just for your understanding. So percentage ko per million mein convert kiya. That's it. So DPMO is nothing but the rejected part and yield is accepted part. See, understand this. Just for your understanding, this is within the specification wala percentage and this is rejected percentage but converted into per million. इतना आप ध्यान में रखिए, ठीक है? Yield meaning accepted within specification and DPMO is defect meaning rejected part but converted into per million. Clear hai? So we need to just calculate the DPMO, convert it and convert it into sigma level, and that is our process capability analysis. Now I will give you an Excel sheet which will help you. Yeah, first pass yield is the okay product without any rework. Without any rework, how many percentage of the product is okay? Okay. So this is available in the define phase process capability analysis. Okay. Define phase process capability analysis. Let me just give you a Excel sheet and that will make your life much easier. Okay. Let me just drop a Excel sheet over here, which is the DPMO calculation. Okay. Let me just close that Excel sheet because it is open in my laptop right now. Okay. Now let me just share that Excel sheet with you. So yeah. So just download this Excel sheet. Can you just download this Excel sheet called DPMO calculation Excel? And it is a done for you Excel sheet. Just put the numbers and it will calculate everything for you. I'll share with you how it can be calculated. Okay. Everybody, just download this and then open it as well. Okay. Let's open that quickly. Once you have opened it, let me know in the chat box. Once you have opened it, let me know in the chat box. Done? Yeah, Ramanuji, this you can find out in your green belt process capability analysis, which is the measure phase. Green belt measure phase, you will find out this. The table which I showed you from the green belt curriculum only. Done, open. Now let me open that as well so that we guys can actually practice on that. Okay. So here, and this is called as the DPMO calculator. Okay. Let's put our numbers here. Let's put our numbers. So how many total number of shirts we checked? We checked the total number of shirts, 100. Okay. Out of which, yeah, opportunities for error in one unit were 5. You put 5 here. And we found out 50 defects. Everybody? So here, you can see here what I've done. What I've done is, so number of shirts were 100. So this is number of shirts. 5 is number of defect opportunities. And how many defects actually observed were 50. So I just put all the numbers and I got 1 lakh DPMO. And this is the actual sigma number, which is approximately we found out 2.75. Actually, it is 2.78155. And there is a formula. I'll give you the formula as well. I'll give the formula as well. So this is 2.78 sigma process.
So 2.7 is the defect, not the defective, no?
Defect. It's a 2.7 is sigma level.
2.7 is the defective level.
Defect level, not defective level. Defect level.
Yeah, sorry, I'm into the defect level, not the defective level.
Correct.
Means out of the 10 lakhs, 2.7 products are defective.
No. Out of, let me explain it once again. Okay. Here, let's say, for example, what was the DPMO ka formula, if you remember? DPMO ka formula was number of actual defects. Okay. See, defective, we are not calculating right now because in the defective, we could not capture the actual total defects which are coming, right? So number of actual defects divided by number of.
It means, sir, in one shirt, there could be 5 defects. Maximum 5 defects
Correct.
could be there in one.
In one unit.
In one.
Exactly.
Yes.
Exactly. Okay. So this is the formula. So into 10 raised to 6. So number of actual defects. So we checked 100 shirts. So total number of units were 100. So in the denominator 100. Total number of defects in every shirt were 5. So total number of defect, DO meaning defect opportunities. And so we checked 100 and out of which we counted how many defects we could find. Let's say 50 defects we could find. So that's what we have written, 50 defects here. There are 50 defects out of 100 shirts and 5 defects per shirt. So the answer was 1 lakh. So 1 lakh is a DPMO number. See, if you don't convert into sigma level, it's also okay. You can keep DPMO number also as a process capability indicator. That 1 lakh is your process capability. That's it. Okay?
That
Yes?
sigma actually means out of 10 lakhs, 2.7 products are defective.
No. There is not sigma. Okay? Yes, sigma क्या है? If you remember, हम लोग 6 sigma निकालते हैं ना, 6 sigma. If you remember the Z score. In the process case, CPCPK में हम लोगों ने निकाला था वो formula. If you remember that. Okay? That is that sigma number. Sigma number मतलब क्या है? Standard, how many standard deviation I can fit between my mean and my specification limit. That number is that sigma number. Okay. So I will not go back to that formula today. Only I will give you the calculation formula, what formula we use to convert DPMO to sigma. And the formula is this. Okay. Just take down this formula. Just take down this formula. So I'm just clicking on this formula. You can see here. The formula is, let me write down in a big letter so that you guys can. So formula is norms inverse INV, norms inverse in bracket 1 minus DPMO number divided by 1 million, DPMO number divided by 1 million, bracket close, plus 1.5. Okay. So this is the formula to calculate this sigma number. If we put this formula in Excel and just put that DPMO number में आपका DPMO का number डाल दो and you will find out this. Okay. I've already given you this Excel sheet. Formula already inbuilt है इसमें. Okay. And this 1.5 क्या है? This 1.5. This 1.5 is nothing but because there is a short-term sigma and there is something called long-term sigma. Short-term and long-term. These are the two terms basically we basically calculate. So what happens is, because we have taken only some short, small sample, okay, generally, this is called the DPMO for a sample, okay. When it comes to a large scale, like if you remember in a CPCPK, there was another part which is called PPPPK, which is called long-term process capability. How many of you remember long-term process capability? I spoke about PPPPK as well. How many of you remember I differentiated between CPCPK and PPPPK both? Do you remember that? Yes or no? Everybody, the people who attended that session, do you remember I differentiated between CPCPK, which is short-term process capability, and the PPPPK, which is long-term process capability? Same
My
fundamental.
question is very simple. If DPMO is 1 lakh out of 10 lakhs, then how sigma could be 2.7? I understood the opportunity is 5 in one product.
Have you? No, just a second. Have you attended that CPCPK wala session?
No, sir. Might be I was out of session.
Exactly. So I would
That's why
urge
I'm
you
confused.
just check out that session, because that is the continuous data. For the continuous data, the formula is completely different, and the sigma level is used for the continuous data, but you can convert that as well. DPMO को भी sigma में convert कर सकते हैं.
But basic mathematics is there. Out of 1 lakhs, let's say we are talking about the search. ठीक है? In one shot, the maximum opportunity is 5. Means it is minimum. If I will talk the probability, 20,000 searches are defective. If I am going to in a maximum level, there is a in one shot there is a probability of getting 5 defects. Means out of 10 lakhs, 20,000 searches are defective. If I am not wrong, minimum. If I would say
20,000 shirts. नहीं समझा नहीं मैं.
See, in DPMO you are saying the DPMO number is 1 lakh.
हाँ, correct. वो clear है, वो clear है. DPMO clear हो गया आपको?
Yeah, DPMO is very clear. DPMO is the opportunity.
हाँ, yes.
Means out of, if DPMO is 1 lakh, then defective product is minimum 20,000. It could be differ. That depends upon the formula.
We can't say defective products out of which.
Defective, see, sir, in one product, the chances of getting defective product is 5.
5, correct.
Opportunity is 5. Means, let's say, मैं मानता हूँ, let's assume there are 5 defects in every product.
Correct.
Minimum 20,000 products are defective.
5 defect opportunities are there, not 5 defects. See, there is a correction here.
Yes, I understood. Sir, 5 defects are there.
Potential
है. Yeah, potential defects are there. I am assuming, let's say, probability, going on a mathematics, basic mathematics, let's say every product has 5 defective. Minimum 20,000 products are defective.
Okay. Understood.
It could be greater.
Okay, understood.
Then how sigma could be 2.7? My concern is this.
Sigma का उससे आप compare मत करिए, वो confusing हो जाएगा. That's what I'm saying.
Okay. Sigma is I understood the mean value and the limits. वो अपना जितना sigma fit होता है, that I understood.
See, exactly. That is what I'm talking about. So उसका DPMO में आप जो conversion कर रहे हैं ना, सो एक्चुअली यू आर आस्किंग मी टू एक्सप्लेन दिस फॉर्मूला. ओके, इसलिए वो थोड़ा कंफ्यूजिंग हो जाएगा. उसको और उसको कंपेयर मत करो. इवन इफ यू से डीपीएमओ का ही कंपेरिजन करेंगे, दैट इज गुड इनफ. ओके, आप डीपीएमओ तक ही रहोगे ना, दैट ऑल्सो विल बी अ गुड इनफ फॉर यू टू. ओके, मेरा आज का डीपीएमओ 1 लाख है, मुझे प्रोजेक्ट करके मेरा डीपीएमओ को कम करना है. फ्रॉम 1 लाख आई हैव टू ब्रिंग इट डाउन टू 25,000 और मे बी 10,000, एंड दैट इज माई प्रोजेक्ट. दैट इज माई प्रोसेस कैपेबिलिटी. क्लियर है? नाउ why I'm
Sir,
not explaining sigma right now here, because that will be too confusing. Because ये जो आप बोल रहे हो ना, उसको कंपेयर करना will be a little difficult task है.
हेलो सर.
हाँ, यस, बोलिए बोलिए.
सर, इसमें थोड़ा सा कंफ्यूजन है कि वी हैव 100 शर्ट्स.
हाँ
We have 100 shirts and total number of defects is 50.
हाँ
And opportunity will be 5 in every shirt.
हाँ,
Yes, sir.
करेक्ट.
So defect will be we have mentioned here 50 defects. So you mean these defects are only in 10 shirts?
No, that's what I'm saying.
Maybe.
See, अभी let's say एक शर्ट है, राइट? एक शर्ट में पोटेंशियली 5 डिफेक्ट है.
Minimum
Okay.
10, sir, his question is minimum 10 shirts are defective.
No,
He's
see,
very, sir,
minimum,
if
हाँ,
out of
लेकिन वो
100,
नंबर
50 defects are there,
see,
and the
understand this.
opportunity is 5, then
Understand
out
this.
of 100, minimum 10 shirts are defective.
हाँ,
He's saying that
लेकिन that number
it
does
could be
not have any,
different.
that
ये हो
number
सकता है
does not
50
have any
प्रोडक्ट भी
meaning.
डिफरेंस हो.
Correct.
तब में एक डिफेक्ट होएगा तो 50
So,
शर्ट डिफेक्टिव होंगे.
हाँ,
बट
so
मिनिमम 10 प्रोडक्ट्स आर डिफेक्टिव.
मिनिमम 10, बट उससे हमारा कोई लेना देना नहीं है. अंडरस्टैंड दिस.
But sir, what he is saying कि minimum 10 products are defective, maximum 50 products are defective, and the
Correct.
data is in between 10 and 50,
Correct.
depending upon the sampling.
Correct.
If
But
I'm
that
not wrong,
is so. But that is
I'm
shirts
just
which we
talking
are.
about the basic mathematics.
No. We are. But see, the point is, we are talking still. We are talking about the shirts. In the DPMO, we are not bothering about shirts. We are just counting the number of defects. Shirts को भूल जाओ. Forget about shirts. We are
Yes, sir.
only
Let's say,
counting the defects. Understand this?
sir,
Let's
my
understand.
confusion is there. My confusion is
Just
here.
hold on. Just let me complete this point.
Just allow me 1 minute.
PPM is where we are counting the number of defectives, which is shirts. In the DPMO, we are not counting shirts. We are only counting the number of defects.
Yes. Just allow me 1 minute. Let's say the example we are reflecting on the screen. We have 100 numbers of samples. We have 5 opportunity in every search.
Correct.
And 5 number of defects are there.
Correct.
Mathematically, minimum 10 certs are defective and maximum 50 certs are defective. Maximum could be. It could be anything. It could be but the minimum data and the maximum data will be ranging between the 10 and 50 only.
Correct.
That I understood because my mathematics is very clear.
Correct.
I might be not clear about the sigma. If the opportunity is 5 and 50 defects are there,
Correct.
तो minimum defective certs out of 100 should be 10 and the max अगर एक शर्ट में एक ही डिफेक्ट है, एक से तो कम होएगा नहीं सर.
Correct.
50 डिफेक्टिव शर्ट्स हो सकते हैं और एक हर शर्ट में 5 डिफेक्ट है तो 10 हो सकते हैं.
Correct.
और ये जो रेंज होएगा दैट विल बी बिटवीन द 10 and 50 ओनली.
Correct.
Yes, that is the main question. Then how sigma is coming 2.7?
So that's what I'm saying. Ki the point which you are driving is defective, which we are not considering here. ये अगर हम लोग लेट्स से फॉर एग्जांपल मिनिमम 10 डिफेक्टिव होंगे, नहीं तो फिर 50 डिफेक्टिव होंगे. लेट्स से 20 एक्चुअल डिफेक्टिव है, लेट्स से पकड़ के चलो. बट हियर इन दिस डीपीएमओ कैलकुलेटर वी आर नॉट कंसिडरिंग डिफेक्टिव एट ऑल. उसमें हम लोग पीपीएम कैलकुलेट करते थे तो बराबर था वो. सो 20 डिफेक्टिव आउट ऑफ 100 इंटू 10⁶, दैट माई पीपीएम नंबर. ओके, ये हो गया डिफेक्टिव का नंबर. बट हियर वी आर नॉट कैलकुलेटिंग दिस पार्ट. We are just counting out of my 50, out of 100 shirts, total number of defects which can come is 500. 5 डिफेक्ट हर एक शर्ट में आ सकते हैं. टोटल शर्ट से 100. सो टोटल नंबर ऑफ डिफेक्ट्स आर पोटेंशियल डिफेक्ट्स आर 500. आउट ऑफ 500 कितने एक्चुअल आए हैं जो मैंने काउंट किए हैं, वो मुझे 50 मिले हैं. तो 500 में से अगर मुझे 50 मिलते हैं तो 1 लाख में से कितने मिलते हैं? दैट इज माई सिंपल डीपीएमओ का कैलकुलेशन. अगर हम लोग 6 सिग्मा में हमें सिग्मा टर्म में इसको कन्वर्ट करना है, तो ये हमें एक फॉर्मूला दिया गया है विच इज नॉर्म साइन वी इंटू 1 माइनस डीपीएमओ का नंबर जो आया है हमारा, जो अभी आया है 1 लाख, उसका नंबर डालेंगे डिवाइडेड बाय 10 लाख, 1 लाख डिवाइड बाय 10 लाख प्लस 1.5. ओके, नाउ लेट्स से 1.5 को फिलहाल के लिए बाजू में रखते हैं बिकॉज दैट विल बी टू कंफ्यूजिंग फॉर अस. नाउ ये फॉर्मूला हमें एक्चुअली सी, ये फॉर्मूला आया कहां से है? Coming back to this, let me just go back to that this wala Excel sheet. See, just try to understand this. ये जो है ना, ये जो टेबल है सिग्मा टेबल, ये सिग्मा टेबल में जो यील्ड परसेंटेज है ना, यील्ड परसेंटेज, ट्राई टू अंडरस्टैंड दिस. सिग्मा फॉर्मूला अभी एक्सप्लेन करना क्यों डिफिकल्ट है. ये यील्ड परसेंटेज, ये यील्ड परसेंटेज आया कहां से है? ये यील्ड परसेंटेज आया है द एरिया अंडर द स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन कर्व. ये जो एरिया है ना इसके अंडर का, ओके. सो इसका मतलब क्या है? जस्ट फॉर अ लेमन्स लैंग्वेज, इफ दिस इज द प्रोसेस और ये अगर पूरे प्रोसेस का एरिया 100% है, ओके, तो उस 100% में मेरा 99.99966% जो है ये विद इन ये रेंज में आएगा. और थोड़ा सा जो है ना, ये वाला जो बाहर जा रहे वाला पार्ट है ना, दैट पार्ट इज माय डिफेक्ट पार्ट. ये जो हम लोग यहां पे कैलकुलेट कर रहे हैं डीपीएमओ में. लेट्स इसलिए मैं बोल रहा था कि ये जो यील्ड है, यील्ड which is the area within the specification limit, and the defects is the area which is going out of the specification limit, and this is calculated with the area under curve. sigma calculation में area under curve का calculation होता है. if you remember z table हम लोग यूज करते हैं, z table, वो z table भी area under curve का ही calculation है, ओके. और उसको यहां पे एक्सप्लेन करना इसलिए वो थोड़ा सा डिफिकल्ट है, इसलिए मैंने सिर्फ आपको फॉर्मूला देके छोड़ दिया. सो डीपीएमओ
my
को
question
डायरेक्टली
comes
सिग्मा
from
सिग्मा
like
में कन्वर्ट करके नहीं एक्सप्लेन हो सकता. जस्ट अ कंपैरिजन कर सकते हो उसको, ये कंपैरिजन है उसका.
when you search on a Google what is Six
हाँ
Sigma, the
हाँ,
answer will be 3.4 defects per million.
करेक्ट.
3.4 defects per million. It means the answer will be the percentage of acceptance sample will be that 99.99 somewhat you are saying in a table.
666%, करेक्ट.
Yes.
99966%, एग्जैक्टली.
Is it true that out of 10 lakhs, only 3.4 products are defective? Not defects. Number of defects are not 3.
Out of 1 million defect opportunities, if only 3.4 defects have come out of 1 million opportunities, then
Okay,
it is
okay.
called
It's
Six
not
Sigma.
out of, not, it doesn't mean out of 1 million product, the
No,
3.4
no,
products are defective.
no,
Out of 1 million defect
correct,
opportunity,
correct.
3.4, you
Defects
got it,
have
got it.
come.
Yes, 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 got it, now got it.
Got it? Yes.
Yeah, yeah, yeah.
Yeah. If you talk about defective, then it is going to ppm. Okay. But now we are talking about defects, only defects. Okay. We are not talking about defective. इसलिए मैं shirts के बारे में नहीं बात कर रहा हूँ, only मैं defects के बारे में बात कर रहा हूँ.
No, sir. I'm a civil engineer. We have a
हाँ.
multiple number of defects.
Yes,
And
yes,
we
yes.
have 100 numbers of opportunity as well in a single product.
So आपके लिए let's say for example, let's say आपने कॉलम बनाया, तो आपके कॉलम के लिए let's say स्ट्रेंथ, कंप्रेसिव स्ट्रेंथ के लिए प्रोसेस कैपेबिलिटी अलग होगी, ओके. मे बी विड्थ के लिए प्रोसेस कैपेबिलिटी अलग होगी. आई एम जस्ट गिविंग यू वेरी रॉ एग्जांपल.
Yeah, lateral dimension. Yes,
डायमेंशन
yes,
के लिए अलग होगी. सो प्रोसेस कैपेबिलिटी अकॉर्डिंगली यू हैव टू कैलकुलेट सेपरेटली. क्लियर?
Yeah, for the compressive strength or the other required strength, it will be
करेक्ट.
different.
सो कंप्रेसिव
For the
स्ट्रेंथ के लिए
lateral
अलग प्रोसेस
dimension,
कैपेबिलिटी.
for the eccentricity, it will be a different.
परफेक्ट. ठीक है, सुपर गुड.
Yeah, thank you.
All right. So I think any other question which is not answered or not clear? Are you clear? So मैंने टेबल किसने मांगा था? I think किसी ने शेयर किया. कलेटी जी ने शेयर किया है. राहुल जी, you got the table, right? Let me share it once again. And by the way, below the recording, I will give the table once again so that you can download that. Okay? DPMO calculation नाम है उस टेबल का. It is again open, so that's why it is not. Got it now? Okay, fantastic. Chalo. Yeah, what is the difference between defect and defective? The difference is a complete unit is defective. It is called to be defective when, see, every unit has got multiple defects, right? So I gave example of a shirt. So in shirt, there are multiple defects like stain, there is button missing, there is stitching errors, etc. So even one defect comes, that makes that entire shirt defective. So defective is a terminology used for the entire product, and defect is used for the number of opportunities which come, either number of defects which can come, multiple defects can come. So button can be missed, stitching error, it can be stain, it can be a fabric problem. Okay, so there could be multiple defects in one unit. If you are counting the defects, you go for defects, and actually defects is a very important parameter for us to calculate rather than defective. Okay, that's why DPMO is much better characteristic to calculate rather than PPM. PPM will give us the defective rejection, but DPMO will give us exactly which defect is making more contribution in the rejection and where we can do the project about. Okay, so yeah, any other question? If you have any question, please let me know if I have not answered, because a lot of questions I can see in the chat as well. Have I answered all the questions? DPMO and Sigma ka. What is the relationship between DPMO and Sigma? So DPMO and Sigma meaning DPMO goes up, Sigma goes down. It's very simple. DPMO is defect, na? See, DPMO is defect and the Sigma number is a capability number. So defect goes up, capability goes down. Defect goes down, capability goes up. So it's inversely proportionate. Okay. Stone is defect and rice is defective. You can say that. You can say that. So you can use your analogy for this. Now, for example, let's say if you are working in a BPO, for example. So let's say call is a unit. Let's understand. Call is a unit. Okay. Now in the call, there could be multiple defects. For example, if call is interrupted in between, that is one defect. Okay. If the average duration exceeds, let's say average duration for resolution is 5 minutes, but at call exceeds to 7 minutes or 8 minutes, that's a defect. Okay. So as a call as one unit, how many defects are there in that call? You go to a restaurant and ask for a thali. Now, how many defects can come in that? So the thali is a unit, and how many defects can come? Okay, there could be multiple defects. Let's say your chapatis, your roti is not properly cooked or baked, whatever it is. Okay, your rice is not cooked properly. Your sabzi is not proper. So entire thali is a unit. In that, how many defects can come? You can count them. Okay. Similarly, in your product, how many defects, potential defects are there? Make a list of it, and then you can calculate your own DPMO number and then convert that into Sigma number with the table or with the Excel sheet. And that is your process capability of what you can say, of a discrete data. Clear? Super clear, everybody? Just give me yes in the chat box.
बट सर वन क्वेश्चन, अगर उसमें डीपीएमओ या डिफेक्टिव बढ़ेगा तो सर सिग्मा वैल्यू कम कैसे होगा? सिग्मा तो बढ़ेगा ना, क्योंकि जैसा सिग्मा का वैल्यू है 3.4 या समथिंग, तो ये हो गया 6 सिग्मा। सिग्मा का वैल्यू मेरा बढ़ते जाएगा, 3.4 का जाएगा, वो अगर 50, 100, 200 कुछ भी होगा तो उसका मतलब डिफेक्टिव ज्यादा है ना फिर उसमें।
ये देखिए, सो फॉर एग्जाम्पल, ये देखिए, सो मेरा अंडरस्टैंड दिस, एज माई डीपीएमओ is 3.4, मतलब very small defects है, तो मेरा sigma is 6 sigma. Okay. Now let's say from 3, my defects are coming to 1000, let's say. So my sigma number is dropping to 4.5. Can you see this? Okay. So as my defect increases, my process capability reduces. No. See, defect ज़्यादा है मतलब क्या है? मेरा process कम capable है. See, it's very simple. If I draw like this, let's say 6 sigma process will be like this. Understand this? ये मेरा है अपर स्पेसिफिकेशन, लोअर स्पेसिफिकेशन, बहुत ही कम डेटा बाहर जा रहा है. नाउ माय प्रोसेस इज स्प्रेड इज इंक्रीजिंग. लेट्स से मेरा प्रोसेस अभी इस प्रकार से है. ओके, तो थोड़ा सा मेरा डिफेक्ट बढ़ गया. नाउ मेरा डिफेक्ट बढ़ गया मतलब मेरा डीपीएमओ बढ़ गया. इफ माय प्रोसेस स्प्रेड इवन इंक्रीज देन दैट, लेट्स से if I draw it like this, so what will happen? Even more defect on both the direction. My DPMO will even go up and my sigma level will go down. As the defect increases, the number of defects, इसका मतलब क्या है? मेरा curvature ज्यादा बाहर जा रहा है specification limit के. And more my curvature goes outside of the specification limit, more and more defects I am creating and my process capability is reduced. और जितना मेरा process capability, sigma मतलब क्या है? मेरा process capability. How capable is my process? 6 sigma in this table is the highest process capability. Is the highest capable process is 6 sigma process. Okay. Yes. And then as my defect goes up, my sigma, my process capability goes down. Our role is to reduce the defect and increase my capability. better the capability, better will be acceptance to the product. See, it's very simple. It's my cash on the table. My number of rejections are high. I'm losing my cash. Customer is rejecting my product. Customer is not paying for it. Yes, it's exactly inverse. So sigma level is inversely proportionate to their DPMO level. Clear, everybody?
Got it, sir.
Yeah, got it now? Very good, very good. Super. Any other question? Please let me know. Super. So if no question, then we'll just sign off. This will, we'll put this recording in the masterclass archive. You can refer that. And you have started about the tools in between discussion started. Tools for discrete process capability. Yeah, these tools now. So whatever we have studied today, PPM and DPMO, these are the two discrete process capability tools. Okay. So the CP, CPK are for the continuous data, and for the discrete data, PPM and DPMO. These are two tools we have to use. That's it. Okay. Done. Very good. Super. So yeah. So for tomorrow, if you want to refer somebody, okay, we are putting the link in your WhatsApp. Already, I think our team has given you the link. We will in our community, in our LMS system, learning management system, there is a community tab. Okay. In the community tab also, we will start putting the link as well. You can copy that link and share it with your your colleagues, team members, family, friends. And if somebody comes along with that, you get a referral bonus of 40%. You all know that, right? Okay. Definitely. See, whichever session you want, this to be taken in detail, no? Just put that topic in the on this number. Okay. Just put a topic request on this number, and we will definitely schedule that value stream mapping, whatever topic you want, okay, to be covered in details. Okay. Just save this number, this admin or mentor's number, you can say, and any topic you want, you can request for that, and we will schedule that. All right. Superb, guys. Thank you very much for joining in. We will connect again on Monday with a new topic with the same enthusiasm. Till the time, keep learning, keep growing. This is